Good evening, everybody. Welcome to Chem 170 with your host, me, Dr. White. Hi, everybody. Tonight I'll be doing test number 2 review. Remember, test number 2 covers alcohols, thiols, epoxides, ethers, aldehydes, and ketones. By the way, Dr. White loves aldehydes and ketones. They've been good to me. I've been good to them. And the other functional groups too. Now, let me remind you that in the lecture section of D2L, you'll find test number 2 review, which I'll be using tonight. You may have to scroll to the bottom and you'll see a button that you have to click on to see more. I don't know why D2L does that, but they do for a real lot of files in a folder. But don't forget, scroll to the bottom and look for where it says see more, or however it says. All right, let's get to work. All right, let's start with alcohols. And alcohols are a carbon with a OH group, hydroxyl group. How do you name them? You find the longest chain or ring with the carbon with the hydroxyl group, the alcohol. Name it as an alkane. Drop the E, add OL. And for acyclic, you need a number. What carbon is the hydroxyl group on? And that always gets highest priority, lowest number closest to the end of the chain. Remember, you always start numbering acyclic compounds from the end of the chain. Now, for a ring, when there are no other functional groups, which is what's going to happen in this class, no number, because that hydroxyl group is always 1. Now, when you have a benzene ring with a hydroxyl group, an alcohol, that's called phenol. This is the common name that was used eons before IUPAC was established, and IUPAC decided, guess what? We better use the same name as the IUPAC name. Don't forget in a benzene ring to put the double bonds, 3 of them. All right, next. Let me move me down here. Maybe over here. All right, next. Let's look at common names. And common names for alcohols, name the R group that the OH group is attached to as an alkyl group it is, and add the word alcohol at the end. And don't forget, rubbing alcohol contains, depending on which type you buy, anywhere from 70 to 90% isopropyl alcohol. And isopropyl alcohol, isopropyl group, and the center carbon is the hydroxyl group, and that's how it got isopropyl alcohol. Now, IUPAC is 2-propanol. Nobody ever uses that, except to say nobody ever uses that. I did. Oh, another use of alcohol in hard spirits, my favorite, vodka. And I also like Canadian Club. I'm not a scotch or drinker. And tequila, well, one night in Guadalajara, I gave up tequila after that. But anyways, remember another alcohol, ethanol, you can find that in gasoline. You know, when you go to a gas station, you'll see a sign, this gasoline contains up to 10% ethanol. And you now know ethanol is an alcohol. Now, how can you make an alcohol? Well, this is the only reaction I can have on more than one test, test 1 and test 2, a double bond, acid catalyst, that's H plus water. Remember, water is HOH. You break the pi bond, one carbon gets H, the other gets OH. It follows Markov-Coste rule. The carbon with the most hydrogens of the double bond gets the hydrogen. The other carbon gets the hydroxyl group. Now let's talk about reactions of alcohols. And probably one of the more challenging this semester is dehydration of an alcohol. Dehydration remove water. And here, if you take an alcohol that has a carbon next to it adjacent with a hydrogen, reacted with sulfuric acid and heat, you lose HOH, water, and between those two carbons, you form a double bond, and it follows Zayseff's rule. And Zayseff's rule is you get the molecule or the double bond alkene that has the most, and listen carefully, carbon atoms directly bonded to the carbons of the double bond. Again, you get the alkene, if you have a choice between two different ones, that has the most carbon atoms directly bonded to the carbon of the double bond. And let's take a look at an example of that. And if we take this molecule and react it with sulfuric acid and heat, what do you see that's different? Hopefully you've been watching the videos and hear me say many, many times, when you look at an organic molecule, look for what's different. What's not a carbon-carbon single bond or a carbon or hydrogen atom should get your attention like this. Hopefully you heard my whistle. And OH, oxygen, on a carbon, ooh, I forgot a hydrogen here, is an alcohol. And we have a carbon with a hydroxyl group, adjacent carbon with a hydrogen, reacted with sulfuric acid, heat. You'll lose OH from one carbon and a carbon next to it called adjacent, a hydrogen, that's water, and between the two you'll form a double bond, and that follows Zayseff's rule. You get the double bond that has the most carbon atoms directly bonded to the carbons of the double bond. Well, if we look at this molecule, two adjacent carbons, which I've labeled A and B, both have hydrogens. So if I lose the hydrogen from A and the hydroxyl group, remember, in a reaction in this class and most of the time in organic chemistry, do you break carbon-carbon single bonds? No. Well, I'm not going to. So if I lose the hydrogen from here and the hydroxyl group from here, I'll form a double bond between those two carbons. Now, if I lose the hydroxyl group here and a hydrogen from B, I'll form this molecule. Do you break carbon-carbon single bonds? No. So I have 4 cross plus this methyl, and the double bond will be between these two carbons. And the question is, which one is the product you get? Now, on the top one, you have 3 carbons directly bonded to the carbons of the double bond. In the bottom one, B, I only have 1 directly bonded. You don't count the 2 CH3s. So this has 1 carbon atom directly bonded to carbon's double bond. And now you have to use your high-level math skills for my class. Which is the greater number, 1 or 3? And time's up. Hopefully I'll pick 3. And the answer is this, not this. That's Zayseff's rule. Now, some other reactions, which are a lot simpler. If you take an alcohol and react it with HX, which is an acid, hydrohalogen acid, where X can be chlorine, bromine, or iodine, you replace the OH group on the carbon that the OH group was with the halogen, and you get an alkyl halide. Now, HX can react with a double bond. So if you had a molecule with an alcohol and a double bond in it, you wouldn't want to use this reaction. By the way, I won't do that on test for you. But another reaction that if you had a double bond, you could still convert an OH to halogen, in this case chlorine, is an alcohol with SOCl2, thionyl chloride, and replaces the hydroxyl group with a chlorine. Now, I talked about primary, secondary, and tertiary alcohols. I will not ask what's a primary, secondary, tertiary alcohol on test 2 or the final, but if you have a primary alcohol and O in a brackets means oxidation reagent, like potassium permanganate, sodium dichromate, and a whole lot more, which I'm not making you memorize. I'm using the general way of saying something is oxidized, O in brackets, right here. And you lose a hydrogen from the carbon with the hydrox group and a hydrogen from the hydrox group, and you form a carbon-oxygen double bond, and we make an aldehyde. If you take a secondary alcohol and oxidize it, you lose this hydrogen on the carbon with the hydrox group and this hydrogen on the hydrox group, and you form a carbon-oxygen double bond, and you form a ketone. Dr. White's real happy because I love aldehydes and ketones. Now, a tertiary alcohol will not oxidize. And as I've mentioned in the videos on my tests and the final, if I ask you, give the product or products of a reaction, the answer, no reaction, will never, ever be correct. If I ask you, give the product, there's going to be a product. So that's one reaction you don't have to know. Now, I talked about thiols. Thiols is the sulfur equivalent of an alcohol. Carbon with a sulfur, and that sulfur has a hydrogen. And the two things you should remember about thiols are, one, they stink. Oh, they stink. Think about skunk odor. 70% of the liquid a skunk sprays, I think it's about 70, is two different thiols. I talked about it in the lecture, but you don't have to know which thiols. And the rest is water. And if you've ever been by an animal that's been skunk or where skunk let loose, you know, oh, wow, stinks. Now, I talked about that tragic event, that tragedy in a small town in Texas, about 1935, where because of a gas leak, the school exploded and killed a tremendous amount of students and teachers, injured a lot more. And that was because back then, methane, natural gas, is odorless. Nothing was added to it. Because of that tragedy, thiol, T-butylthiol, is added to natural gas so you can smell it. How stinky are thiols? Well, if you've ever smelled natural gas, you know it's got a strong odor, and but they only put about 1 to 4 pounds of thiol in waiting for this, billion pounds of natural gas methane. That's how stinky they are. All right, next, I talked about ethers. And ethers are an oxygen with two R and R prime groups. Remember, R prime is just like X and Y in math. R is something with carbon and hydrogens. R prime is something and carbon and hydrogens. They can be the same or different. That's why we use the prime. And I didn't ask you to learn the IUPAC name rules for naming out ethers. I know them, but for this class, use the common name, name the R group as the alkyl group it is, and add the word ether at the end. And as I mentioned, Diethyl ether was the first inhalation anesthetic used, and it came into wide use, unfortunately, during the American Civil War in the 1860s. Now, I also mentioned, go back and look at the video, the newer ethers that when I had to have I hate to think about it, double hernia operation, uh, that was the inhalation anesthetic I was first given. Then you also had intravenous anesthetic to keep you under for a long time. And by the way, if you're wondering, yes, I survived that operation. All right, now how do you make an ether? The Williamson ether synthesis. RO minus Na plus alkoxide plus an alkyl halide gives you an ether plus salt. And X can be chlorine, bromine, or iodine. Now, the carbon with the halogen is the carbon this oxygen is bonded to in R prime. The carbon in R prime with the halogen is the carbon that this oxygen is bonded to in R prime. Now, one of your colleagues asked, on test two, I think there's 3 or 4 synthesis problems, unlike test one, which I only had one. And the question is, well, how can I find practice for synthesis problems? And it's easy. Go to the practice problem answers. Cover the starting material. You have organic, inorganic reagents, and then a product, and you figure out then what's the starting material, and you can remove your hand and see what the answer is. All right, next I talked about epoxides, but only one, ethylene oxide, which you don't have to know the name. But you have to know if you take one molecule of an alcohol and ethylene oxide, I got the hiccups. And react it with ethylene oxide, one molecule, you'll get this ether alcohol. And this is a very good surfactant. And I talked also about the deep well horizon oil spill and how this chemical made by ethoxylation of an alcohol was used to disperse the oil in the water, but unfortunately killed a lot of the marine life there. And the people who were doing the cleanup, it caused problems, health problems with them too. That's in the video. Now, if you take an alcohol and react it with N moles of ethylene oxide, you get this polyether alcohol, where OCH2CH2 is repeated N times, where N comes from the coefficient, the number of moles of ethylene oxide used. Now, both of these reactions, I will never put a synthesis problem on my test or final, but you should know how to give the product or products. That's not what I want. That's what I want. And the question would be, give the product or products or the following reaction. And if you want, you can hit the pause button right now and do the reaction. And hopefully you've hit the start button again and look at this. And we look at the first compound here, what's different, what's not carbon, what's not hydrogen, what's not a carbon-carbon single bond. Should get your attention like that. Ooh, OH group on a carbon, alcohol. And we got, 5 moles, N moles, and this is ethylene oxide. Oops. And what you get is this polyether alcohol, where N here comes from the coefficient M there. Remember, the hydroxyl group is outside the bracket. What's our R group? These three carbons. You break carbon-carbon single bonds? No. So whichever carbon the hydroxyl group is on is the carbon this is bonded to, this polyether. And what's N? 5. And then outside the bracket is the alcohol. And these are very useful too. And you find them in shampoos and a lot of personal care products, air conditioners, all sorts of things. Now we moved on to aldehydes and ketones. An aldehyde is an R group on hydrogen on a carbon double bond to oxygen. A ketone are two separate R groups. They can be the same or different, bonded to a carbon, double bonded to an oxygen. For aldehydes, you name the longest chain with, this is called the carbonyl carbon, the carbon that's double bonded to the oxygen, name it as an alkane, drop the E, add Al. Since the carbonyl carbon is always number 1, you don't need a number. But the rest of the alkyl groups, you name and number, starting with the carbonyl carbon is number 1. Now in a ketone, you have named the longest chain that contains the carbonyl carbon, carbon double bond to oxygen as an alkane, drop the E, and now for a ketone, add ONE. Now, if it's acyclic, not in a ring, in a chain, you need a number. And the carbonyl carbon has priority, numeric priority. That means it gets the lowest number closest to the end of the chain. Now, cyclic in a ring, you need no number because the carbonyl carbon is always number 1. It rocks. Dr. White loves aldehydes and ketones. See, I'm smiling. Now you know I'm an organic chemist. All right, I asked you to learn 2 common names. The simplest aldehyde, when R is H, is formaldehyde. Nobody calls that, let's have to think about it, methanal. It's called formaldehyde. And the simplest ketone, when R and R prime are methyl, is called acetone. Remember, acetone is a very good nail polish remover. And I will never give the common name for these, but I will ask, draw the structure from the common name. Now, something very important, so important I wrote it in red, and that's the carbonyl group. The carbonyl group is not a functional group, but you should know, hint, you should know how to draw the carbonyl group. That's right here, carbon double bond oxygen with 2 things attached to it, and how to describe it with words. And how do you describe the carbonyl group with words? It's a carbon atom double bonded to an oxygen atom. Again, there's nothing more important to Dr. White and all of organic chemistry, hint, than the carbonyl group. And you should know how to draw it. Carbon double bond to oxygen with 2 things attached to it, and how to describe it with words. Carbon atom double bond to oxygen atom. Now, how do you make an alcohol? Well, we've talked about it already, so I'll go through it quickly. Primary alcohol. How do I make an alcohol? How do I make an aldehyde? primary alcohol oxidized to an aldehyde, secondary alcohol oxidized to a ketone. Now, a very special way of making a special type of aromatic ketone is Friedel-Crafts acylation. And that's where you take a benzene ring. This is called an acid chloride with aluminum trichloride, and the carbonyl carbon and the acid chloride, this right here, bonds to the benzene ring. And you make this very special thing, a carbon-carbon single bond, and you make an aromatic ketone. Now, the next four, actually 5 reactions, I'll never ask for a synthesis problem. What's the starting materials? But I will ask what it would be the product or products are the following. And the first reaction is making a hemiacetal or hemiketal, take an aldehyde or ketone, and R prime, when it's carbons, is a ketone. When R prime is hydrogen, it's an aldehyde. Reacted with 1 molecule of alcohol, acid catalyst. Keep your eye on the carbonyl carbon. What's attached to it, R prime and R double prime, or the H instead of R prime, still there. This opens up the OH and OR, where the OR comes from this alcohol. Now, always keep your eye on the carbonyl carbon of a ketone or aldehyde, because that's where the fun is. And actually here, I forgot something. Oops. And there, aldehyde and ketone, now 2 molecules of an alcohol acid catalyst, and you form an acetal or ketal. Now, these 2 reactions here, Mother Nature uses to make carbohydrates, which we'll talk about later in the semester. Now, a special case of the second reaction that was discovered by, or created, really, wasn't discovered, he created it, invented it, by my advisor's advisor, PhD, Herbert Stork, Dr. Stork, at Columbia, I believe. Take an aldehyde or ketone, reacted with ethylene glycol and acid. Now, ethylene glycol has 2 alcohols in the same molecule, and you get this cyclic compound. Now, do you break carbon-carbon single bonds? No. So don't forget to put that bond there between the 2 CH2s. A lot of students do forget to do that, so don't you be one. And this is called putting a protecting group on. Later on, you can take it off. Just like if you go outside and it's raining, you'll have an umbrella or you'll wear a raincoat. But when you come back inside where hopefully it's not raining, you take off the raincoat or close the umbrella after it dries off. And this does the same thing, but with aldehydes and ketones protected. But unfortunately, I don't have this time this semester to show how that's used in synthesis. All right, now, once you get the hemiacetal right here, you can revert it by adding acid and water to get back the aldehyde or ketone plus the alcohol you would have used to make that hemiacetal. And where can you find acid and water real quick where you are right now? Your stomach. And we'll learn this, and the next reaction goes on in your stomach to break down carbohydrates and sugars. And we'll cover that later in the semester. Why, that's going to be fun to get into. All right. Now, if you have a acetal or ketal, it undergoes the same reaction. Acid and water, you get back the aldehyde or ketone plus the alcohol you could have used to make that acetal or ketal. Now, these 2 reactions, now, as you know, we don't balance equations, but years ago I had these twin sisters who were very nice except for one thing. If I didn't show all the numbers in the general reaction, like 2 molecules of alcohol, they got really upset. I mean, really upset. trust me, you don't want twins really upset with you. So that's why I have the little 2 here in quotes. You don't have to put it down. Now, how do you remember this? This is the only case in all of organic chemistry that I know where you have 2 single bonded oxygens to the carbon atom, same carbon atom. Again, this is the only reaction, these 2 in all of organic chemistry that I know, where you have 2 oxygens bonded, single bonded to the same carbon. And they both give the aldehyde or ketone and the alcohol used to make those molecules. This reaction, this one right here, I will never give a synthesis problem. That's cruel, unusual punishment. I think the Supreme Court still has outlawed that. Maybe not, but I think so. All right, let's get to something simpler. You take an alkyl halide, carbons with a halogen, react it with magnesium. You form the Grignard reagent. Remember, it's R bond to Mg bonded to X, not RXMG. That doesn't exist. And this is the reagent that the great French organic chemist Victor Grignard created to do some amazing reactions. What makes it amazing? You can get a carbon-carbon single bond. And here, in the next reaction, take an aldehyde or ketone, and this is the way, and I explained in the video, 2 separate steps. The first step, you react it with a Grignard reagent, where X can be chlorine bromine iodide, same up here. Second step, acid. Remember, H plus is acid, like sulfuric acid and water. And you do something very special, very rare. You make a carbon-carbon single bond. I gotta do one of these. Let's have some fun. And if we take this reaction, and the question is, give the organic product or the products for the following. Well, what do? Well, you look at the smart starting material. What's different? Ooh, oxygen double bond to carbon with carbons here and here. This is a ketone. Now, it could have been an aldehyde. Our prime could be H, but it's not. And up here, ooh, carbon-carbon, magnesium bromide. That's a Grignard second step acid and water. And here, the carbon with the Grignard attacks this and opens it up, attacks the carbonyl carbon right there. What's attached to it are prime or hydrogen, our double prime are still attached to that carbon. But you get an alcohol, and now you make that special thing, a carbon-carbon single bond. Now, keep your eye on the carbonyl carbon becomes this carbon, so I'll write that first. What's our prime? Methyl. You break carbon-carbon single bonds? No. What's our double prime? Ethyl. And then I'll have my OH group, and the carbon with the Grignard is the carbon, and here's my R triple prime that's bonded to what was the carbonyl carbon, this one, which is now an alcohol carbon. And one simple step, I made a very complex molecule. And that's the beauty of the Grignard reaction with aldehydes and ketones. It allows you to make that very special, very rare thing, a carbon-carbon single bond. This reaction, I will never give a synthesis problem on. That's cruel, unusual punishment. Now, we have a ketone or aldehyde. Remember, we have one pi bond and one sigma bond. As you learn, if you take hydrogen and catalyst, where catalyst could be nickel, platinum, or palladium, break the pi bond, each atom of the double bond, carbon oxygen, gets a hydrogen, and everything else comes along for the ride. And this is a great way of making alcohols. And you can find ketones and aldehydes in our everyday life that Mother Nature made, and you can use them. Later on, I'll talk about another molecule that you can find in nature that we use heavily in the chemical industry. And I worked for a company where I was laboratory manager for all of North America, where we made that chemical. But you're going to have to wait until we get into fats and oils. Now, if I take the reagent lithium aluminum hydride, LiAlH4, which was invented by a great organic chemist, Dr. H.C. Brown, Herbert Brown, who was at Purdue right around during World War II, and later on won the Nobel Prize for this. If you take lithium aluminum hydride, react it with an aldehyde or ketone, this reacts just like hydrogenation. Hydrogenation up here would also attack a double bond, carbon-carbon double bond if it was in the molecule. In my class, you don't see that. But lithium aluminum hydride will only attack carbonyl groups, carbon-oxygen double bonds. And you have first step fat, second step acid and water, but you get the same thing. You break the pi bond of the carbonyl, one carbon, one atom gets the oxygen gets the hydrogen, carbonyl carbon gets the hydrogen, and our prime or hydrogen and our double prime come along for the ride. And you make an alcohol. And finally, oh, now I'm really happy because we're going to deal with enolate anions. And I did my PhD thesis on a very specialized enolate anion, which most organic chemists is so specialized aren't aware of. But got my PhD in a publication. I learned how to become a synthetic organic chemist. Good stuff. But anyways, and that's the aldol condensation. If you react two of the same aldehydes, you can also do this for ketones, but it's more complex, so I won't put it on the test. But this you should know. If you react an aldehyde with itself in the presence of a base, NaOH, and water, on the alpha carbon, the carbon bonded to the carbonyl carbon, you take off a hydrogen because they're acidic, and this enolate anion attacks the other carbonyl, opens it up to an alcohol. Everything else that was attached to those carbons is still there. And you form a carbon-carbon single bond, always very rare, very special. And with that, I'm almost done because guess what? I think we all need a pick-me-up. I sure do. So let's play that fun game, circle, and name the functional group, 2 points each. And it could be more than one. And let's get some molecules. All right, your turn. And if you need more time, hit the pause button on the video right now. And what are you supposed to do? Circle and name the functional groups, not name the molecules, just name the functional groups, 2 points each in each of A, B, and C. So it's your turn. All right, if you need more time, hit the pause button. Why am I going like that? You know, use your mouse and click on the pause button of the YouTube video, and you'll have more time. But how do you do this? Every molecule, you should always find the functional group. I always do when I look at an organic molecule. That's the first thing I do. And how do I do that? I look for what's not carbon, what's not hydrogen, what's not a carbon-carbon single bond, because that's where the fun is. That's probably going to be a functional group. And if we look at the first one, hydroxyl group, an oxygen with a hydrogen and a carbon. This part you don't have to do, but you should know that's an alcohol. Wait, another oxygen. Double bond to carbon with hydrogen and carbons. This part you don't have to do. But this part, circle and name it, that's an aldehyde. Let's go to B. An oxygen here. Carbons here and here. Again, this part you don't have to RO prime, but what is this? It's an ether. Are we done? Oh no, look, another oxygen. And it's double bond to carbon here with carbons here and here. And what is this? It's a ketone. All right, let's move on to C. I think I threw everything in on C but the kitchen sink. Well, here's an oxygen, double bonded to a carbon here with hydrogen and carbons. This part you don't have to do, but circle and name that. What's a carbonyl with hydrogen, R group, and aldehyde. An oxygen here with a hydrogen and a carbon. Again, you don't have to draw that, but I will, so you see what it is, but I'm going to circle it. And what's a carbon with the hydroxyl group? And alcohol. Are we done? No. There's another oxygen. Boy, there are a lot of functional groups. And here is double bonds at carbonyl with carbons here and here, but they're connected to each other, but it's still, but they're connected. So this is a cyclic, what? It's a ketone, but it's in a ring. And that one had, wow, 3 functional groups. And that's how you play that fun game. Circle and name the functional group or groups, 2 points each. Now, make sure for before test number 2, I hope you've already been watching the videos. I hope you've done the practice problems. Tomorrow night, I will have my office hour. So if you have any questions, come on by and I'll be more than happy to help you. And on Thursday morning, 8 o'clock a.m., or maybe even earlier, I will send out a password that will allow you to open the password protected test number 2 PDF file that you will download from the assignment area of Blackboard. You'll have until I think 4 p.m. or 6 p.m. I think it's 4 p.m. Friday. That's a lot of time to take test number 2. Remember, it's not an open notes test. Please don't. I put things in there to tell me if people are cheating. Dr. White can be very clever and sneaky. But anyways, hopefully you won't do that, please. And take as much time as you need to take test number 2. However, make sure you upload it as a single PDF file, which you all did for test number 1, but now you'll do again for test number 2 by the Friday deadline. By Sunday, 3 p.m. or earlier, I will grade test number 2. I'll post the scores in D2L. And next Monday, I will have Zoom meeting, I believe at 8 o'clock on Monday, where I will go through all the answers for test number 2. If you can't make it next Monday for that Zoom meeting, I will post a private video, send you an email with the link to see that video. And with that, I'm done for the evening. And I'll say, Gang gesund. Remember, that's Yiddish for going hell. Guess what? COVID's still out there. I think next couple of days, I was talking to my doctor today, I'll be getting the newest booster, even though I got my last one in the summer. She said, this is different. It's a good thing to have. And I'm going to get it. I've already gotten my flu shot. So make sure you get yourself protected. So once again, I'll say Gang gesund, Yiddish for going hell. I'll say goodbye. Goodbye now. I stole that from Granny to Beverly Hillbillies. Bye.